All right, guys. So I decided I'm going to do this video in two parts, kind of like in class, because some of you guys only need the first half, some of you only need the second. So everybody who needs both can do it. 1, 2, and 3. Those are the graphs of the sine and cosine function questions. Number 1, like you can look at the graph if you want. Like I can see here that the maximum value is 2. I can see that the minimum value is -2. Or I could just look at the equation and it's the number that's in front of the sine or cosine. That's your amplitude. So number 1, the amplitude is just 2. Number 2, you're finding the period of the function. Although period is like the length. So like if I was talking about this graph up here, it'd be like the length from here to here. Like what is that length this way? There is a formula. The formula is the period is 2 pi divided by b, where b is the number that is in front of your x or your theta that's behind the sine or cosine. If it reduces, yes, please, please, please reduce it. This one happens to not to. So on this one, the period is simply going to be 2 pi over 3, which means it's a horizontal, horizontal compression. It gets a lot shorter. Number 3 asks for the phase shift. No, I'm going to be honest with you. I don't know what it's going to ask for right here. My software is finicky. So I'm just going to label everything so that you remember, and then I'm going to put the phase shift in the answer. So again, the number that's in front of the sine or cosine is your amplitude, which is kind of like number 1. The number that's in front of the x or the theta would be your period. So this one's period would be 2 pi over 2, which would just be pi. Okay, so if I ask for the period, that comes from that number. This particular question is asking for the phase shift, which is the number that's being added or subtracted inside the parentheses. That's your left and right movement. If you remember, almost always, like I can't think of too many times where it's not, your left and right movement, translations it's opposite. So since it's a minus pi over 6, this graph actually moves right pi 6. Minus is right, plus is left. So it shifts to the right pi over 6. And this plus 5 right here is a little deceiving. Normally you would see it like back here, like plus 5 and not in the front. Because that's where I usually wrote it. But you're adding the 5 to the whole function, and this would be a vertical shift, meaning this would move up 5. So just a little refresher on the translations there. So that's 1, 2, and 3, the graphs of the sine and cosine function. Pretty straightforward. Numbers 4, 5, 6, and 7 are all trig functions, that kind of thing. I mentioned in class it would probably be helpful to have your formula sheet for all those trig formulas, as well as your circle. It's going to come in handy dandy. Okay. Now number 4, I'm going to do the ones that need work. Like I'm going to scroll down and do them. Like number 4, for example, you're finding cosecant. Cotangent's -15, so I need to find cosecant. They tell me cotangent of theta is, -square root of 15. And then they tell me that the cosine is negative, right? Did I get all that right? Yeah, okay. Alright, so if you recall, this is the XYR stuff, which is basically SOHCAHTOA and the Pythagorean theorem. So on your formula sheet that I hope that you have, cosecant. Cosecant is the reciprocal of sine. So that's going to be R over Y. Again, that's on your formula sheet. We know cotangent. The same area is Y over X. So that means if I were to write that as a fraction, the square root of 15 over 1. Oh, no, it's X over Y, y'all. Listen, my brain's fried. It is 8:30, and I'm ready for bed. It's X over Y, guys, not Y over X. It's cotangent, not tangent. So that means the square root of 15 is X, and Y is 1. Now, yes, I know there's a negative there, but if you recall, the negative and this thing right here is going to tell me what quadrant it's in a minute, so I'm just kind of ignoring it for a second because it's not important at this juncture. So I know y, right? I know y is 1. Right, I got that one. That's cool. I just need to find r. R is the Pythagorean theorem. X squared plus y squared is r squared. Right, so this is the Pythagorean theorem. So that would be the square root of 15 squared, my pen's being weird, sorry, plus 1 squared is r squared. So that's 15 plus 1. This one's nice because I get 16 as r squared. And of course, we know to take the square root of that because it's r squared. So that means that r is 4. So the cosecant is r over y. So 4 over 1, which of course is just 4. But I need to decide if it's positive or negative. Okay, again, cosecant is just the reciprocal of sine, right? So if you have your circle, if you have your formula sheet, whenever we did tangent, I wrote this down 11 times. We know the signs of our quadrants, right? So, first of all, they tell me that cotangent is negative. Okay, cotangent is obviously negative right here. And cotangent is the x-coordinate divided by the y-coordinate. So that means it would have to be here or here. Because if I divide the x and y coordinate by each other, that's going to give me a negative. If I did that here or here, that would give me a positive. So I know it either has to be quadrant 2 or quadrant 4. Now, the cosine. The cosine, which is the x-coordinate, right? We know cosine's x. We've done that a bazillion times. Is negative. Less than 0 means negative. Cosine is negative right there. It is not right here. So it is not quadrant 4. It's quadrant 2. So my angle is in quadrant 2. Cosecant is sine upside down. Sine in quadrant 2 is positive. So that means that 4 stays positive. So all of that explanation to, yeah, it stays positive. But it's just knowing where everything's positive and negative at. So cosecant is 4. That's your answer to that one. Cosecant of theta is 4. That was fun. Number 5, you have to simplify the expression. I'm just going to do this one right here. This one's really short. Excuse me. I'm going to turn everything into terms of sine and cosine. Again, you hopefully have your identity sheets. I would suggest locating that. Cotangent. So cotangent is the same thing as cosine over sine. That's one of the quotient identities. Times secant is the reciprocal of cosine. 1 over cosine. Sine is already sine. Now, if it helps you, write it as a fraction like the other two, sine over 1, but sine is just sine, it's not going to change. And in this particular identity, my bad, the cosines divide out, the sines divide out, so I'm left with 1. I need to see what you did, so make sure and show that, and your answer is 1. If it's not, you just write down what you got left. Alright, sine is -1. Listen. Okay, first of all, they want my answer in radians, so we got to be careful. And we showed the other day you can't do this one in your calculator and get radians because our calculators are not as nice as we'd like for them to be. So I'm just going to talk about the circle real quick. Okay, that's beautiful. Okay, so we know in our circle, which hopefully you have in your stuff, right? We had all those angles. What it was sine was -1/2. Yeah, that's a half. Okay. So we had all of our angles, right? All the way around. And if you remember, we have an x and y coordinate for each one of them, and the y coordinate is the sine value, and the x coordinate is the cosine value. So really, if you have your circle, all you have to do is look around your circle to see which ones have a y value of -1/2. So I'll go ahead and tell you, it's going to be the one that's going to be right here and right here. Let's see, and it's in radians. So that's what? 1, 2, 3. Nope, not that one. Let's start over. Oh, not that much over. Okay. Wow, this thing's picky. Okay, so 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6. So that's 7 pi over 6. 8, 9, 10, 11, 6. So those are your answers. If you'll look at those two, you'll see that their y coordinates are -1/2. So that's really all you have to do on this problem is whatever value of sine or cosine, go use your reference circle and see where those two values are. So 7 pi over 6 and 11 pi over 6. 7 pi over 6 and 11 pi over 6. That's beautiful. There we go. So finding the exact value of sine of 15, we talked about this in class. You could do it several different ways. Make sure dang it, I'm flipping radians. I gotta change my mode on my calculator real quick because I'm in radians. Okay. In case you didn't know, you can download the Numworks calculator app for free on your phone. Anyway. So what I'm doing, since I know that I'm looking for, hey, it's my bedtime, for my angle, right, I'm looking for the angle, and oops, wrong one, no I'm not, y'all, okay, I'm finding the exact value of sine 15, there we go, that's what I'm doing, my brain's off. We could use the sum and difference formulas, you could use the double angle formula, you could use the half angle formula, so I'm just going to use make sure and put in my calculator correctly. So the sine of 15, and it's telling me that it's the square root of 6 minus the square root of 2 over 4. Okay, so make sure you're writing it in exact form, sine 15, and make sure you're in degrees because I almost was not. All right, so that's the first video. That's where we got to last Friday. A bunch of trig stuff, everybody's favorite. And I'll post the second part in a second.